Thanks. All right, so before we get started, my name is Scott Massler. The gentleman who made these slides is also named Scott. I'm not going to pronounce his last name because I'm sure I would butcher it. So this is the amazing thing about GitHub, and it's the reason that I loved being able to find these slides, because I found them on GitHub, right? And so GitHub gives us a place to share the work that we're doing that is not obviously our business's work, the work that has to be private, but we can share all of this other stuff. All right, so this is an intro to Git. I'm not going to talk about how to install Git, but I'll show you where to get that information. It's super easy, regardless of what platform you're on. Linux, Windows, Mac, it doesn't matter. All right, so let's start with, what is Git? Git is an open source distributed version control system designed for speed and efficiency. So this first part is important. It's open source. That's kind of what I was talking about before. GitHub is a place to put all kinds of different open source stuff, and it is built on top of Git. It uses Git for pretty much everything it does. Because it's open source, you can actually see the source code. You can see the internals of how this program is written, and you can also find out how to get it onto your system if you don't already have it. So git-scm.com, that's where you can get all that information. It's distributed, right? That means that it is fully distributed, and it means that it is almost everything is local to your machine. So you don't need to be on the internet other than to maybe go and get somebody else's work. So once you actually start working on a project, everything that you need, all of the repository is on your local machine, which gives us some benefits. Everything is fast. If you've worked with some of the other version control systems where it saves stuff slightly differently and you don't get the entire thing, it can be incredibly slow because you have to go up and get, any differences, you have to go up and get stuff from whatever server is holding it. Every clone is a backup. So because you have everything from that repository on your machine, everything is a backup. If one of the main servers goes down, you have everything from that repo. If somebody accidentally, gets rid of your repository on GitHub, you have everything on your machine. So everybody that's working on the project has a full copy, as long as they pulled down recently, a full copy of everything out on that public machine. This is my favorite part. You can work offline. I work remotely. I don't work in the offices. One office is in San Diego, one's in Tampa, and I work here. So you don't have to be, if your version control system, if the actual server that stores all that stuff publicly or privately is on a VPN, you just hop on the VPN, pull it all down, and then you don't have to get on the VPN anymore. So another common thing is like if you're working on an airplane. I've never had that happen, but I have not wanted to get on a VPN quite often. So the other thing is that it's designed for speed and efficiency. This was originally designed for dealing with the Linux kernel, which is a gigantic project. And it was designed specifically so that it could work with very large projects very quickly and not have any issues. What it gives you is immutable. So it almost never, very, very rarely, removes any data, which means that if you've already committed something, the likelihood of you doing something to get into a state where you've lost something is incredibly small. Most likely, you can always get back anything that you've committed. And even in some situations, stuff that you haven't. It deals with snapshots, not patches. So I'll kind of walk you through that. So Git uses Delta storage. And the pretty thing about Delta storage, imagine that this is a directory with a few different files in it. Whenever you change one of those files, Git doesn't copy the entire file. What it does is it copies the difference. So it stores the delta on all of these different files. And so as you continue to just store the delta. A delta is obviously very, very small, right? It's only the differences between the original file and the new changes. And as it continues, you make more changes, and it continues to only store the delta of all these files. There's another option, right? And that's snapshot storage. And so what snapshot storage does, in the exact same situation, you've made the exact same change. Instead of storing the delta, it stores a copy of the entire file. So now you have the whole A and you have the whole A1, right? You have the whole C, the whole C1. And so the file space required for this, as you can imagine, gets very, very large, and it slows everything down. And so Git benefits greatly. All of those benefits at the beginning are from this kind of file storage, right? That's what makes it so quick. That's what makes it able to deal with such large projects. Oh, sorry, there's a couple more slides here. So this is very small, this is very big. We prefer the smaller option. All right, so now some of the practical, how do I use Git? A couple first steps. You can do this, you can add globally, so across all of your repositories, your username and your email address. And this just makes it nice. So whenever you do a commit, like maybe on a project that you don't own, you're just helping out on an open source project, or you're doing something for work, every commit that you make will have both your username and your email attached. So if someone wanted to get a hold of you or needed, some information or wanted to know who was making this, it's really easy to find. This is not strictly necessary. It is optional. You don't have to put in a valid email address if that's a problem for you. But I would definitely recommend, if you're at work, it's a good practice. Like, use your work email, and then people know how to get a hold of you. All right, so let's start getting a repo. Git init is one path. There's two different options here. If you don't already have a repository, you're not like getting someone else's repository, this is how you start your own. So git init inside of a directory will start a Git repository there. So we can imagine we've created a directory, we're inside that directory, and now we're just touching a file. If I do git init, then look at what's in that directory now. You'll see like there's a huge tree of things. At the very bottom, you can see that there's the hello world file that we just created, which is sitting inside the directory. And then there's this hidden directory, because it starts with a dot, that's Git. And so you can see inside there, you can see the head, the branches, the config. There's all of these different things that are necessary for Git to be able to do its job, and for Git to be able to store all those deltas and store all the commits that you're going to make. But all that stuff is hidden. So if you just look at the directory and just did an ls of the directory, all you would see is that file that you'd created. But this is how you start a new repository, git init. So the other option, if you want to start a new repository on your local machine, is you can clone. And so what cloning does is it copies someone else's repository, or maybe your repository that you've put on a public server, and it brings it down to this computer. So to run it, you just do git clone, but you're going to need a URL. So in this situation, the URL or the repository is stored on GitHub, and the following stuff is just telling it where exactly this repository is stored. If you do it this way, whatever the folder, the directory that repository we put in is just the name of the project, right? So it'll create a folder called grit and put that on your machine, and then you have to move into that directory to see the repository. The other option is that you can name where you want that, what you want that directory to be called. And then in this case, it would just be my grit instead of just grit. So you do a git clone, apparently with my grit, and you'll see all of this output, the work that Git's doing. So it's reaching out, it's pulling in objects, it's creating that directory, and it's putting everything in it. The other nice thing about this is that it's getting all of the commits, all of those deltas. So whenever this completes, you have the entire repository that was put out there. It's a full clone. So now if we cd into my grit, for those not familiar with Linux or Mac, or Mac, cd is just change directory. I guess that's the same on Windows, right? So you move into that directory, and now if you look inside it, you can see we've pulled down everything that's in that repository. If we would have done an ls-la or another command that would show you everything in that folder, you'd also see a .git, right? So it's there, you can't see it with that command. All right, so let's go through a basic workflow. Are there any questions? That's one thing I should have said earlier. If there are any questions, feel free to raise your hand or just shout it out. I'm perfectly fine with that at any point in time. So if you need something answered, I'd really like to help you out. All right, so basic workflow. We're gonna edit the files, we're gonna stage the changes, we're gonna review the changes, and then we're gonna commit them. One thing before we get to that, Git has these three concepts that you kind of have to understand to really get it. So there's the working directory, which is just the directory that you're in right now. In the previous case, it would have been my grit, right? So it's the directory where all of your files reside. The repository is an object database. So it's where all of the information that Git is storing your commit history and all the changes. That's what that is. And then finally, you have this index area, which is essentially staging, but it's local staging, right? So it's on your machine. All of these things are on your machine. If you're familiar with like a staging environment in dev terms, that's not what it is, right? This is really on your machine, and it's just a place where you can do some work. You'll see it used here in a bit. All right, so first step, we're gonna add some files. So we already have a repository, right, that has a couple of files in it. I'm just showing you what they are here. We have a main.py and an app.yaml. We don't have to care that it's Python. All right, so we opened up that file and we're adding some information to it. We're adding a comment that says that it's just a hello world program. And because we've changed it, right, now we can do a git status. And what git status does is it tells you the current state of your repository, right? So anything locally that's changed or anything locally that's staged, git status is going to show us that. So we run that command, and now we see on branch master, changed but not updated, and then modified main.py. So there's a couple of things that I want to point out here. The first thing is this modified main.py. So git status is going to tell you anything that has changed in your repository, and this is where it's going to put it. So if we would have changed multiple files, all of them would be listed in this section. The other thing is that you see that it's changed but not updated. And what that really means is that it's changed but not staged. So you haven't told Git that you want these files to be in that index, right, in that staging area. All right, so now, because we want to commit these changes, we want to make sure that they're saved, we're going to have to add them to that staging area. So git add is what does that. So we can see back to our working directory, our index, git add takes any changes that have been made and moves them from the working directory to that index area. And that index area, it has to be in that index area for it to actually get saved to the repository. So we run git add main. This is our file that we had changed. And what we see is changes to be committed, modified main.py. So this is different. This is different than what we had before. I'm going to scroll back. Changed but not updated, right? And then we have, oh my gosh, changed but not committed, right? So it went from updated to committed. And what really this means is that it's changes that are staged. These are changes that are on your index. So now all we have to do, oh, no, we're gonna make some more changes, sorry. All right, so we had that app.yaml file. It had a version. We're gonna go ahead and change that to 2. And we're also gonna go back into our main.py, right? And it was Ola world, now it's slightly different. And we're gonna do a git status again, right? So we had staged some changes, and then we went back and we made 2 more changes. And whenever we run git status, this is what we're gonna see. Super weird, right? So we see some changes to be committed, and it has main.py, and then we see some changed but not updated, and then it says app.yaml and main.py again. So this top part is staged, right? Those are the changes that are ready to be put into your repository. The bottom part is unstaged. So if you ran git commit right now, only the top, only the staged part would actually get saved. But you also see that there's main.py twice. So what we had done is we had gone in and we'd made some changes, right? And then we staged those changes. We did git add on that file. And then we went back in and we changed it again. And so what we're going to find is that one set of changes, the changes on the left, are staged, right? And then the exact same line, the changes on the right in the working directory, are not staged. So that's the second set of changes that we made. So if right now we did a git commit, and git commit, we'll get into that, but that's how you save stuff to your repository. Only the changes on the left would get moved over. The changes on the right would stay in your directory. They're not going to go away, but they would continue to be unstaged. I think that this is probably the thing that confused me most of all whenever I was getting used to Git. So it's very helpful to understand. So on this left side is staged, on the right side is not. You have to stage a file after you edit it. After you edit it. This is the part that confused me. After you edit it, right? So if we add both of them now, we'll see git add, app.yaml, git main.py, git status, and we'll see that both of those files are now staged. They're both on the index. And what's interesting is that whatever you had staged before, now that you've added them both again, the updated main.py is what will get staged now. So we originally had hello world, now we have hello mundo, and that's what's going to get staged. Whatever you had there ready to be staged before, or ready to be committed before, is gone, and now you have the updated. Okay, so finally, we have all those changes, we're confident with what they have, or what they say, and we're ready to commit them. So git commit, as I've referenced, is going to be the thing that we use to do that. So before, we had done git add, and we moved the stuff from the working directory to the index, and now we're going to do git commit, which moves it from the index into your repository. So it's just git commit. We run git commit, and it's going to open up a file. So depending upon where you're at, this is what it's going to look like. Well, no, this is what it's going to look like pretty much anywhere. So it's going to open up this file, right? And at the top of it, what we're going to do is we're going to add a 50-line present tense string, kind of describing the changes that we're making, right? So we maybe we just internationalized main.py, and then we skip a line, and then you can write paragraphs upon paragraphs of all the nitty-gritty details of what you've done. But the beauty of this is that that first line in some of the other Git commands we'll see later, whenever you're looking at the history, that line will always appear. So if you write it really clear, like in a kind of a high level of what you did, that's what's going to show up. Some other Git history commands that you can run will show the entire thing. So if you're really curious about what someone did, you can dig in deeper. If you just kind of want to see an overview of what's happened, then you can just look at those first lines. So that's why we do this. And understand this little line here: an empty message aborts the commit. So if you would have done git commit on that git commit, it opens up this file, and you didn't do anything but just saved it, then the commit gets aborted. Nothing will happen. I use this very often whenever I realize, oh, I need to add another file that I didn't add already, or I need to do this other thing. Then I'll just empty it, leave it empty, save it, and then I know that nothing happened. And all that stuff will continue to stay in your index, just like before you ran the git commit. So if you run it, you fill in that the description and everything, hit save, then this is what you'll see. And it'll tell you it created a commit, it'll give you a SHA, or part of a SHA, I should say. It'll tell you whatever your descriptive commit message is, and that'll just be the first line. And then it'll kind of tell you a little bit about what happened. So a couple of files changed, there were a few insertions, and there are a couple of deletions. That's not accurate to what happened just now, but that's what you'll see. All right, so basic workflow over review. We edit files, right? That can be with Vim, Emacs, whatever GUI application you use, it doesn't matter. You stage the files with git add, and then optionally you can add the file. So if you just want to add everything, you do git add and then space in a period, and then I'll add everything in there. Otherwise you can do git add and the file name. You review your changes with git status to make sure that you've only added the right files. If maybe you'd made 3 changes and you only wanted to add 1 file, then you could do git add and that file name, and then you're good to go. You make sure that with git status that that's what you did. You commit the changes, and then I didn't talk about this before, but it is super helpful on that review stage. Git diff, and what git diff will do, there's a large number of file types that are diffable. There's also a very large number that aren't. So like you can't diff an Excel spreadsheet right now. I don't think that you can diff like a Word doc. Maybe I'm wrong. Maybe you can't do that. But any software language, Vim, whatever, that's just a plain text file, all of those can be diffed. And so what you'll see if you do a git diff is you'll see the difference between the changes that you've made and what was there before. So whenever we originally wrote this to the file, all that was there was that red line that's now been deleted. And you can see with the little green pluses that these are the things that we've added. So if you do a git status and you see, I have all of these files, and you really want to understand, like maybe you've been working on this over a week and you really want to understand like all the details, or maybe you just want to pick certain files, you can do a git diff. And you'll just write this all out to your screen, you can scroll through it, and you'll do like file by file by file. And you can just see the reds are removed, the greens are additions. All right. So a little bit more information on git diff. If you do just a git diff, you're going to see the difference between the working directory and the index, right? So that's the differences between what you had whenever you first pulled down this repository or whenever you first initialized it, and what changes you've just recently made that are not yet committed. If you want to see the difference between what is staged and what's out there on the branch, wherever, you can do a git diff cache, or sorry, whatever you've already committed. And what you'll see is the difference between the index and the repository. So if you want to make sure that the changes that you've made are actually doing the thing that you want it to do against whatever's in production or whatever is on your master branch, this is how you do it. All right, so we're going to get into a little bit of the internals of Git, just so that we can kind of understand what's happening. Whenever we run this git commit command that we showed earlier, you can see that there's like this short little 6-digit, or no, maybe it's 7 digits, bit of a number there. And what that actually is it's just the first few characters of a 40-character SHA-1 checksum, right? And what this is essentially works as is an ID for the specific commit that you've just made. It's really kind of cool. So it's a checksum of your changes, what was there before, the stuff that's already in Git. And so it's just a unique number that you can use to reference this exact commit, and it's super handy. One nice thing about it is that if anyone else, if you're working on a project together and you've already pushed up your changes and they pulled them down, you can reference that exact commit, that exact SHA, and it'll be the same for them. Right, so if you want to ask them to look at something specifically, you can send them that number and they can look it up. Oh, okay. What's the question?
All right, make sure. Is the mic on? Okay. It says, so a file is not in the database before you add it and commit it?
Correct. It's not stored in your, yeah. Oh, are we good with that? Mm-hmm. Okay. Yeah, so it's not actually stored in your repository until after you've added it and after you've committed it. Up to that point, it's only in your local working directory. Good question. Okay, so that's a SHA. It references a specific commit. If we get there and you all are interested, I'll kind of show you some fun stuff at the end, what we can do with that. Branching and merging. All right, so this is one of my favorite bits about GitHub or Git. It's kind of complex to understand, but once you get it, it's super simple. It's really not a bad concept. It's just kind of hard to wrap your head around it. So if we have questions here, please ask, because it's kind of hard to explain as well. So we're going to start with branches. Branches are these lightweight, movable pointers to a specific commit, right? So we have all these commits, and you'll usually see them whenever somebody's talking about Git. You'll see like this C0, C1, C2. That's really just referencing like different commits, just so that's what it is. All right, so how do we branch? Git branch is the command that we use to do that. Git checkout is the command that we use to move to that branch. So typically with Git projects, it's not default. The master branch is called master, but that branch is just like any other branch. There's nothing special about master, which is why the guy who wrote these slides actually called it default, was just to get that in your head, right? There's no difference between master and any other branch. And some Git flows even use that differently. So what we have right now is we have default that's pointing at the first, or at commit 1, and then commit 0 is the first commit, right? So these go, the numbers grow right as you move along. So there was an initial commit, and then maybe somebody changed something. And you see up at the top, head is pointing to default. That's important. So we're going to create a new branch, right? We're going to do git branch experiment. And because head is pointing at default, head is where we currently are, right? Head is what our working directory looks like right now. And it's pointed at default. Whenever we do a git branch, head, or the branch that you do this git branch from matters, right? So you're going to branch from the point that you're currently looking at. And it can be a little bit difficult to understand whenever there are multiple branches. We'll get through that. So now we have 2 branches. We have the default branch and we have experiment. And we really want to be on experiment, right? Because we're starting some new project and we want to kind of branch off and be able to work on our work there. So git branch, just running the command git branch, will show you all of the branches that you currently have created. And they'll put that little asterisk by the one that you're currently on. So that asterisk tells you where your head is pointed. Head is really your working directory. All right, so now we're going to do git checkout experiment. And you see how head went from default down to experiment. So what that's telling you is that now whatever is on experiment is what's going to occur in your working directory. That's the work that you're actually going to see. Okay, so we're going to do a little bit of work. We made a commit, we made some changes, and now you see it goes CO, C1, C2. And C2 is connected, or experiment is pointed at C2. Default is pointed at C1. So if you switch branches back to default, you're not going to see that commit C2. The work is not gone, it's just on a different branch. All right, so that's what created that. We're on that branch. We're going to commit again. So now we have C2 and C3. Neither of those commits are on default. Does that make sense? Everybody see that? Like, it's default only knows about C1. That's as far in this history that it understands. Experiment knows about C2 and C3. Now we're going to get checkout default. So default only knows about C0, C1, doesn't know about C2, C3. Experiment is still hanging out on C3. And head is back up to default. So now we're only going to see in our working directory C0 and C1, whatever work we did there. Now this is where it's fun. We're going to commit from default. So now there's a commit that default knows about that experiment doesn't know about, and experiment knows about those other two commits. Our head is still pointing at default. So now we can git checkout experiment, and we can do another commit. So now there's these three commits that experiment knows about, default knows about, one special one. And whenever you do this, like, this is super common. This is everything that you do in Git, because what'll end up happening is that you'll be doing some kind of work, and then your boss will come to you and say, hey, we need a quick fix for production. And so you hop over to master, or you hop over to whatever branch is directly off, or maybe you branch straight off of master. That's what I would do. And you create a new commit, and that goes straight into master, right? And so your experiment branch doesn't need to know about that's the work that you're working on that's going to take 2 weeks or 3 weeks, and then this quick fix just can get straight into master. But what we're going to need to do at some point is we're going to have to merge these two branches, right? So like, this work that you've done matters, and it's branched off of this master branch, and ultimately you want these two things to be together. So git merge is how we do that. Whatever branch that you're on is the branch that's going to be merged into, right? So right now we're on experiment. If I did a git merge and specified the branch, then default's changes would get merged into experiment, but that's not what we want. We want our changes to be merged into default. We want our changes to be merged into master in this particular situation. So I'm going to git checkout default. You see, if we did git branch, you would have seen that we were like, our head was, the asterisk was by experiment. Now we want it to be by default, so we moved up. And what we're going to do now is we're going to do git merge experiment. So we're going to name the branch. We're going to run git merge and name the branch that we want merged into the branch that we're currently on. And what that's going to do is it's going to create a new commit. And that new commit has two parents, right? You can see from the two arrows, it comes from commit 4 and commit 5. And it's going to take all of that work and put it into the branch that I'm in right now. So now, default knows about all the work that was done on an experiment and all the work that was done in the line on default. Sometimes you'll run into like issues with merge failure, like there's conflicts between, maybe I made some changes on C5 that are on the exact same page, on the exact same lines as C4. And so I have to choose, like, the computer Git doesn't know which ones you really want. And so it'll kind of show you this this pane where you can pick the things that you want, like which changes do you want. Maybe you pick a couple from the experiment branch and a couple from the default branch and merge them all together. It's pretty common. Usually Git can figure it out unless you've changed the exact same line. So you see it has two parents. Cool thing about Git is that you could do merges from multiple branches, not just two. So you're not limited to two. There's a thing called an octopus merge, which is like multi-headed. I don't know what the upper limit is. I don't know that there is an upper limit. So if you, I know in the Linux kernel, there's an example that I think has 30 or 40 branches all getting merged at the same time into one branch. I have never had to do anything more than 2 branches. I don't suspect, unless you're working on the Linux kernel or unless you're working on some ridiculously huge project that has a large number of committers, I can't imagine that you would ever have to do that. But just know it's out there. Like Git is the stuff that you have to know to use Git well is not very wide, but Git is incredibly deep and gives you an incredible amount of commands, some of which can do the exact same thing, just with more than one command. It's awesome. It's my favorite thing about Git. You can be as crazy as you want. All right, so we're gonna check out experiment again. So our head has moved back down to experiment, and we're gonna make another commit on that branch. This isn't exactly how I would do it, but it's perfectly legitimate, right? Like usually I would start a new branch, but there's absolutely nothing about this that's wrong. So you've merged all of that stuff back into default, so it knows about all the work on C2, C3, and C5. And now maybe there's just a little bit more work that I want to do that's really related to that exact same thing that I was already doing. But the changes like weren't necessarily breaking anything, so it was fine to merge back in. So now I've made another commit. I moved my head back up to default again, because that one commit maybe was a fix, maybe I just did something silly. And now I need to merge that back in, so I'm gonna do git merge experiment. And so now you can see there's an additional commit, that C8, that has two parents again, the C6 and C7. And so all that work that you've done is back into your default branch. Does this all make sense? Or no questions? This was so confusing to me, so like, yeah, good luck. It's amazing. Okay, so remotes. Remotes are what make Git so versatile. So I said before that it's a distributed workflow. So we have the ability to have two people that are both working on the same project. Just to be clear, those two blue boxes are the same public repo, right? So it's not two different repos. The difference is that one of them is the master branch on the left, and the other one is the experiment branch on the right? So, and then you have two people that are both working on the same repo, bottom one and top one. Those are two separate independent computers working on the same repo. So you can see this bottom person has these three commits, A, B, and C, and they're going to git push, oh, wrong way. They're going to git push those up to the master branch on the public repo, right? So now the public repo knows about A, B, and C. The other user is going to pull those changes. So do a git fetch, which pulls those changes from that public repo down to their computer. Apparently they had already cloned it. And they're going to go ahead and add some more commits, right? They're going to make some more changes. And they're going to push those changes up using Git. Git supports SSH and also Git. And so now that experiment branch knows not just about the first three commits, but also about the three commits that user added. And then that user is going to go ahead and pull those down, maybe check them out. GitHub kind of replaces this. So you don't have to do all of this work in Git. GitHub is going to show us how to do some of this work on the GitHub website. So that user pulls down those changes, and then they commit them. They say that, yeah, these changes are good. Maybe this bottom person is the person who's responsible for the repo or owns the repo, and says, yeah, those changes are good, so he pushes them back up to that master branch, right? So now both changes that they'd made are up on the master branch in the public repo. All right, so multiple remotes. This problem is also kind of solved, or completely solved by GitHub, but it can be really helpful. I'll show you how this flow actually works whenever you're using GitHub. It's slightly different, but this is perfectly legitimate. So like if you just had a server that everyone could get to, you could do this exact same workflow without GitHub, and you would just use standard Git methods to accomplish everything. So GitHub is not strictly necessary. You can totally do it without it. So bottom person has the repo. They're going to commit the changes. This is the tree of all the changes. That's blobs. They're like the most finite bits of the changes. And they're going to push that up to a public repo, right? This is not on GitHub. This is just, they all have the same server. So this first developer, Nick, is going to clone that project and is going to add some additional work, right? And then this other user, Jessica, is also going to clone the project, and she's going to add some additional work. And then they're both going to push up their own projects, right? So now, the person who owns that initial project is going to git remote add, and then the link to their GitHub, right? And that git remote add really just gives you another avenue. So like whenever you do a git clone, what it's doing behind the scenes is it's git remote adding the location of the repo that you just cloned, right? Whenever we get to GitHub, you'll see like whenever you do a git, before you do a git push for the very first time to the GitHub, you have to add that remote. So this remote that he's adding is really just a reference to Nick's project. So we do a git remote add. You can see that it's Nick and Nick. We're going to do another git remote add to add a link to Jess's project, right? So that way we know that we can fetch from both of these places. We know all the different locations that these repositories are stored now. So now we can do a git fetch Nick. And what that's going to do is it's going to go out and it's going to get Nick's changes and it's going to pull them in to our repository. This doesn't merge it, right? This just puts it in our repository so we know about that branch. And then we're also going to do a git fetch Jess, right? So we're going to go and grab the stuff from Jess's project and pull that down as well. And now we can merge. Oh, we are going to do a three-way merge apparently. So we can merge all those changes. We can merge Nick's changes, we can merge Jess's changes, and put all of that work into our master. And then we can push that up. So basically what we've done is we've said, okay, all the work that Nick did, all the work that Jessica did, it all looks good. I'm going to merge it in so that now my master branch knows about all of their work. And now I can push it up and make it public so that anyone can pull that back down.
You did the fetch, was that creating branches as the master branch?
Yeah, right? So you see Nick master, right? So Nick had already committed that work to his public repository, his master branch. And so whenever we do that git fetch, what we're really doing is pulling his branch in and saying, and just creating another branch really in our repository. But it's a branch that points to a remote repository. And the same thing whenever we do Jessica's, right? So we've pulled in a branch. This is similar whenever we get to GitHub, you'll see that we'll have like a Git origin master, and it's similar. It's really just the public repository. We're pulling in whatever changes were there, and then we're going to make it in our own and push it up to our private repository. It could also be public, but our repository, and then we'll push it back over. So yes, good catch. Does that make sense? So we have a branch, just another branch, just a regular branch, but it just happens to point to a remote repository. And then we push it public, and now we can just say and see, like, those changes that Nick made are on his project, but see how his project doesn't have all the stuff that Jessica made, right? Only the public project has it. Like only our public project has it. And the same thing for Jessica. We have her changes, she has her changes, we have them on our repo, we have them on our public repo because we pushed it up, but Jess doesn't have any of Nick's changes. And then obviously we have our changes as well, right? And neither of the other two have those. What they could do, if they wanted to, is they could pull, both of them could pull from that middle project and then push it back up, and now everybody's on the same page. So remotes are just branches, like we found out from that perfect question. We have my repository. I've got a couple of changes. Jessica has fetched my repository, or fetched from my repository. So now she has a Scott default, and then she also has a default branch that's pointing at the same place that Scott default is. And all that is right there is a git clone. Right? So we both have our own defaults, and then she has one that tells her, I cloned this from his repository. And then she does some work. On her default, so whenever you git clone, whenever you're pulling from a remote repository, you have a snapshot of the most recent, of the changes from whenever you made that call. So if I go and make some changes, she doesn't have those changes. Right? So she would have to pull again or fetch again to be able to get those additional changes that I've made. So any of those remote calls are always going to be at the point from when you made the call. They won't have any additional changes. You have the right to choose when you want to pull those additional changes in. All right, so she's pulled them in. So now her Scott default has all the changes that mine does, and her default branch has some changes that I don't know about. And maybe she branches off her default and adds those experimental changes, right? So what she could do is she could hop onto the default branch. She could do a git merge experiment, and that takes all those experiment changes and merges them into her default change. And then she hops on, and then she just stays on default, and she git merges my branch. So now her default branch has all of the changes from both her experimental branch and her and my branch. A remote branch is simply a local pointer to the last known state of another repository. So that's what I was saying, is whenever those additional changes are made, she doesn't know about them because she only knows the state of whenever she made that call originally. So why is this cool? Nonlinear development. So you can clone the code that is in production. You can create a branch for issue 53 in this case. You can work for 10 minutes on that because that's probably all your boss is going to give you. And then someone asks for a hotfix issue for some other issue, right? So now you can check out production, which is usually master. You can create another branch, and you can call it issue 102. You can fix that issue, check out production, merge that in. We're going to use GitHub for that in the future, but that's one way that you could do it. And then you push production up. And then you can hop right back over to what you were working on before you were interrupted and just continue on your way, right? And so you have all of these different, as many rooms for the work that you want to do, and they don't have to conflict with one another. And you can hop between them whenever you feel like it. All right. Oh, this is just it's a more visual representation of what we just talked about. So we have our origin master, we have our production, they're both pointed at the same place. We hop off, we want to work on issue 53, we make some commits, and now our boss just interrupted us so rudely, and now we have to do some work on issue 102. So we're going to commit that change, right? Apparently it's a super simple change. And we're going to do git checkout production, git merge issue. And so now that work has moved into production, right? And it hasn't affected our issue 53 branch. It doesn't know anything about the work that you did. So you push that up, and now origin master knows about it, and you continue working on the issue that you had been working on. Oh, okay. So now maybe there's some more work that you have to do on that branch, right? Maybe you didn't quite fix it the first time. Oh no, version 2, sorry. So maybe you wanted to try a different option. So maybe you had been working on it, you realized that you were going down a path that you didn't particularly like, you didn't really want to refactor everything, so you just start a new branch and just start working on it all over again. Maybe you've learned something. Maybe the class that you thought was a class was actually a module, and now you have to rethink everything that you've done. So you can just hop off of it and go work on something else. It just gives you another path, and maybe you get this far into version 2, and you realize, oh no, I was right before. So you can hop back over to what you had before and continue working on it. It's incredibly helpful whenever you just want to try out an idea. Whenever you want to isolate work units, whenever you have long-running topics, so you have branches that you need to work on for a long period of time. And what it ultimately provides us is just pain-free context switching. So obviously, like, context switching as a developer is not good whenever other people are forcing you to do it, but whenever you want to do it, super helpful. Git gives you that. History. So this is what's amazing. So we've made a ton of commits, right? We've made 50 commits where we're looking at the Rails project or something that's really old, and we want to look at what's all the steps that have been taken to get to where we are now. Git log gives that to us. So we run git log, and now we can see all these commits. And see, these are the single lines that I was talking about before. So git log just lets you see like a high-level view of what all the changes were that you've made, or that have been made. So that whole block is one commit. It's all the information from one commit. So it's got the commit and the SHA up at the top. It's got the author of who made these changes. It's got the date the changes were made on, and it's got that little string of what actually has happened. Oh, and now I'm going to point out all of those things again. So it's got the commit SHA, it's got the author, it's got the date, and it's got the actual words for what were changed. Git help. Obviously, we can't remember all of these commands all the time. So if you know the name of a command, but you can't exactly remember how it works, or maybe you don't remember all the options that are available for it, git command -- help. Another way of writing that exact same command is git help, and then whatever command it is. Honestly, one of the best places to get information or to get help or try to find new places where you can learn more information about Git is git-sem. That's the place where all the stuff is from. All right, so let's go over basic review of the commands. There are 12 of them. Oh no, I got another question.
Question
All
from
right.
the chat. What's the difference between a fetch and a merge?
Fetch and a merge. Okay, so a fetch, everybody heard the question? Oh, he's got a mic. Okay. So a fetch is whenever you go to some repository that is not your current repository, right? And you pull changes or you pull a branch from that repository to your repository. So like on GitHub, we're pulling the stuff that's out on the public repo down to our local repository. A git merge is whenever you're taking two branches that are in your local repository. So those can be remote branches that you fetched in, or those can be branches that you've created, and you're combining those branches together. Make sense? Awesome. All right, so the first command, we learned this a long time ago. It's probably, we're gonna remember it. Git init. That's whenever you wanna create a new repository in your code base, or on your local machine. You haven't already started something else somewhere else, you just wanna create it right here. Git clone is whenever you want to pull someone else's repository from another server or from wherever. You can even do it on your local machine, and create a new repository right where you are. Git add is whenever we've made some changes and we want to stage them. We want to put that on the index. Git commit is whenever we've made some changes and they're sitting on the index, we've already staged them, and we want to move them from that index into our repository, into what we have we've committed and what's saved. Git branch is whenever we're on, you're always on a branch, right? Your head is always pointing at some branch. Typically it's master, that's where you start. But then you can, git branch is how you create a new branch, or how you want to, git branch just by itself is how you see all the branches you have created, and you can also see the one that you're on right now. Git branch with a name is how you create a new branch. And that name, with most things in Git, or most things anywhere, it has to be like all connected. You can have underscores and dashes, and maybe another special character or two. But usually it's just a name and then a dash, or multiple names connected with dashes. You can't have any spaces. But that's how you create a new branch. Git checkout is how you move between branches. Git merge is how you combine two branches. Git remote by itself, I think just shows you the remotes that you have available, but it's only the names of them. And then git remote add is how you create a new remote, and it takes a URL. So if you want to add a GitHub remote, then you can go out and I'll show you where to get that information, but you can pull it in pretty easily. Git push, git fetch, sorry. Git fetch, as we just talked about, is how you pull remote branches into yours, or remote work into yours. Git push is how you, whenever you've had committed changes, that's how you push something up to a remote repository. Git diff is how you see changes either between your repository, or your working directory and the index, or between the index and the repository with -- cached. And then git log is how you see the history of all the work that has been done. And this is all the commands that you need for the vast majority of work that you're going to do with Git. That's it, really. So we have some resources. Git, SEM, as we've already talked about. GitHub, obviously built on Git, offers training. Most of it is free. I think some of it's paid, but most of it's free. And so if there's additional information that you want to learn about Git, they have these free courses that are great. And then on IRC, hop in Git, GitHub. Both of those will give you help if you need any help with that. All right, so that's the end of that first part. Man, I'm going long. It's whatever. All right, so let's hop over and let's look at some GitHub stuff. Oh, hey, no. Yeah, oh, this is gonna be weird. All right, so this is my standard user, and this is my other user. All right, so I've already gone ahead and I've created a, oh man, I'm gonna have to do that too. All right, sorry, 1 second, let me grab, I don't even know where, there it is. I'm gonna pull this over too. Oh, hey, good call. Oh, he's so smart. Oh, and I can't, oh, is that working? sorry. Displays, arrangement, mirror. Sweet. You can tell I do this a lot, right? Okay. Thank you for the help. Okay, so we have two different users here. This first user that you can see that is not in the incognito browser. Can everyone see that? I'm going to make that a little bit bigger. Has logged in, and this is the user that I used to create this repository, right? And so, why don't we do that? So I've got, oh man, that's small too. I've got this, this is the repository, right? This is the one that I created. It's got a README in it, so let's make a change real quick. All right, I'm gonna save that. And so now if I do a git status, you can see exactly what I was talking about. So you can see that that's there. I'm gonna do a git add. I'll do a git status again. So now you can see that that's staged, right? It's green now on my computer, and you can see the changes to be committed bit. And I'm gonna commit it, which opens up the display I was talking about. And so I can add a commit message. All right, I'm just gonna save that. All right, so now if I do git status again, there's nothing there, but it does tell us that that my origin master is ahead, or that this branch that I'm on right now is ahead of my origin master by 1 commit. And what that means is that obviously I just committed something, but my origin master doesn't know about that commit yet. I haven't merged it. I haven't pushed it in this instance. So I do a git log. You can see there's that first commit. That first commit was whenever I originally created this repository and I committed it, and then that second commit is what we just did. And now I'm going to git push origin master. Oh, let's talk about that real quick. So you can see I have a remote. I'm going to forget this command. Dash V, yeah, thank you. Git remote dash V. So what that does is just verbose, like tell me everything about this. So you can see I have one origin. It accepts a fetch and it accepts a push, and you can see like that's the URL for that repository on GitHub. So now I'm going to do a git push origin. So I'm telling it what branch do I want to push to, right? And master. Since I only have one branch, I could technically just do git push, and it would push the branch that I'm on right now to the only remote place that I have. That's why you saw like that earlier. So I'm going to push, and you'll see it's doing some work. It's pushing that up. And now, if we go back over to GitHub, and I refresh it, maybe. Okay, so whenever we were doing everything locally, right, you can just merge whatever you want. But usually whenever you're doing something remotely using GitHub, you'll see that there's that there are other people who are in control of that repository. So you can't just merge whatever you want to. You have to open up a pull request. And what a pull request is it's just saying, here's one commit, or here's this list of commits that I pushed up. Essentially, here's this branch that I pushed up. And I want you to look over those commits. And if you like them, you can merge them. And if you don't like them, then you can tell me you don't like them. Question?
We have another question from the chat. How do fetch and clone differ?
Okay, how do fetch and clone differ? Git clone is whenever you're originally wanting to grab some repository and pull it down locally. So it's going to pull everything from that repository, and it's also going to create that remote that I was telling you that we just looked at. So that way you know where you can push information back up to. A git fetch is once you already know about this repository and you want to pull something down from a specific, or from that repository, pull any branches down that have already been put up there.
Is it all the branches, or do you fetch up branches?
No, it'll pull all the branches. Yeah, it won't. So if I do git branch, right now I only have master. Oh, because I didn't branch. That's awful. Man, I'm not showing good things here. Here, let's fix that. No, I'm not gonna fix it. It'd be too confusing. There's a lot of things that Git can do. It's crazy. Okay, so it shows all the branches that I have, which is the only one right now, and it's just master because I haven't pushed up any branches from anywhere else. Okay, so we're over here, and I want to create a new pull request. So all I did, whenever you go to a repository, up at the top, there's a pull request tab, and I'm just going to create a new pull request. So what it's saying right here up at the top, where it says base master and compare master, right now it's comparing only to itself. So both those masters is the same, right? And it's like down at the bottom it says compare and review just about anything, but there's nothing shown right there. Whenever you actually are comparing two branches, then you can do it. Oh, did I not actually push that branch? Oh my gosh. Okay, that's what. Never mind. I have control over that repo, so I just pushed right over the master. That's not a good thing to do. So I'm going to check out let's do it the right way. Git branch and talking, right? Because that's what I'm doing. I'm going to do, if we do git branch right now, you see there's two branches. A little asterisk says I'm a master, so I'm going to get check out talking. And now if I do this, you'll see that now I'm on that branch. And so if we look at the README again, it already has both those changes. And the reason is that I just pushed my master branch, which is the production master branch, or the repository's master branch. So those changes just got immediately put in because I have the rights to do that. If it was a different user who didn't have those rights, then it would just blow up and say, no, you can't push this. All right, so I'm just gonna add an exclamation point this time. All right, so you can see, so you can see in that comparison, the top one doesn't have an exclamation point. It looks like it's been deleted, but really what's happened is that something got added on that second line. So I'm going to git add status. You can see it's there. I'm going to commit. Nope. And that's what happened. I'm gonna write that. And now look, I have a different branch, and so I'm gonna do origin talking, right? So it's the first part is the remote that I want to push to. The second part is talking. I could also do just git push, but I'm so used to doing that because I usually have multiple remotes. So now you see down the bottom it says new branch talking. So I should have caught on that didn't happen before, but I just completely missed it because I'm talking. So now if I go over here, this is what I was hoping to see. So I go back there. GitHub is super helpful. And so it assumes that because I just pushed up a new branch that, hey, you might want to create a merge request, right? A pull request. Those are the same thing. But I'm not going to go that direction just in case, because sometimes if you have pushed it up and then you waited a while, you won't see it. So I'm going to show you the other direction too. So I'm going to go back to pull requests. I'm going to hit a new pull request, and then like before, but now you can see that there's another branch. And if I would have been as a different user, like not the user that actually owns this, then you would have seen like the name of the user for that GitHub profile and then / in the branch. So that way you just know where it's coming from. So I'm gonna click on talking. And so now what you can see is I have this create pull request option, and then it's essentially just a diff, right, of all the files that are diffable. And so if I would have had multiple files, you would see all of those files down below. And so you can just kind of look through and make sure that you actually pushed up what you wanted to push up before creating a pull request. And then you can create a pull request. And then if you've only got one commit, then it's just going to use the title and the description from that commit. If you have multiple commits, then these are empty, and you can put in whatever you want to. And this can be different. So like if I realized, I shouldn't be talking, then I can change that, and it won't change the commit. It'll only be on this merge request, right? So it'll only exist on GitHub. And then you can scroll down. You can see what's there. You can click on. Oh no, I can't click here. You can also display the rich GIF if there's more, or there's different ways that you can view this file if you click on that. All right, so I have a pull request that I want to do from master, or from compare to master, from talking to master. I've updated everything. This supports Markdown, so you can preview it if you've made something cool, and then you can create the pull request. And so now this is what, if you are the ability, question.
Question from the chat again.
Shoot.
How do you correct a bad merge?
How do you correct a bad merge? So it kind of depends if you did it to master or if you did it to a different branch. If you did it to your production branch or you did it to a different branch. If it's just your own branch, then there's lots of ways and you don't have to worry about it too much. So so let's say reading me, and I accidentally added a puts boom. Oop, and that's not even correct. So I definitely didn't want that. Oh my gosh. And so I didn't want that. I git add, I git commit. This is shorthand if you have a commit that you don't really care about, but I would always advise using the other way where you can actually put in everything. But because this is an accident, I'm just going to do it this way. And so if we do git log, you can see that that's there. Okay, so there are a couple of different ways that we can do this. We'll do the safest way, right? Because that sounds good for this. So what I'm going to do, I'm going to do git reset soft head 1.
There's supposed to be 2 dashes.
There are supposed to be 2 dashes. It's like a modifier. A lot of Git commands, a lot of Linuxy commands use that style. So what this is going to do is it's going to, you know, we're on the head, right? Like that's where our working directory is. That's what's pointing, and that's where we're at. So if I do this little command, what it's going to do is it's going to take the first commit on this branch, and it's just going to take it off, but it's not going to destroy anything, right? So it takes that commit off, so that commit is like it never happened, but all the stuff that I had committed is going to show back up in this directory. So if I do that, if I do a git diff, sorry, oh my goodness. If I do a git status, you'll see that it's still there, like the changes are there. They're staged, like they're ready to be committed. So that's one way to get out of a bad situation. If you've done a lot of stuff, let's commit this again. I'm thinking carefully about what kind of commands that I want to show people who might be new to Git, because some commands are kind of dangerous. Dangerous is too strong a word. There's always a way to get out of it. Some commands are harder to revert from to get out of that situation. So one of the things that we can do, so we see that we have all these different commands, there are all these different commits that are there. What we could do if we wanted to get back to a previous situation is we can, all I did was I copied the SHA from that git log. And like I said, the SHA is a way to always see whatever it is, you know, whatever commit you were at. So one of the fun commands that Git gives you is you can check out a SHA. So this is exactly like checking out a branch, but instead of actually checking out a branch, what you're doing is I want to go back to this exact moment in history, this exact place in my commit tree, and I want to see what that looks like. So now you can see, like, GitHub is going to tell you, hey, there's some different problems here. You're in a detached head state, which means that you're not attached to a specific branch, which is very easy to fix. You just do git checkout branch. But all it's saying is that you're on this exact commit. You're not on a branch. And that commit has the history of all the commits that were before it. So you can still see everything that happened before. If we do a git log, I checked out the first commit. So that's all that we can see, right? And so what you could do, if you were really confident that you'd messed up all these other things and you'd push something to master and you really don't want to do that, you go back to that branch and make sure that you're at a good spot. And then you can do git reset hard. So soft pulls off the changes and puts it into your index like they've never been committed, right? Git reset hard just blows that stuff away and says, I don't want any of that, right? So, and actually before I do that, I need to git checkout master. Because that's where I want to reset master. I messed up master like I just did a couple of minutes ago. And so now I want to reset it so that none of that stuff is on there. So what I can do is git reset hard, and then the SHA. And what this will do is it blows away all those other commits that I've made, right? So if you had accidentally made a change on master, you can git check out and have a new branch. And so like if we go look at, so master only has one commit on it at this point in time. But if we do git check out, talking, and we do a git log on it, we still have all that stuff, right? And so if you had accidentally merged something into master and you pushed it up to your production thing and you didn't want that to happen, then this is how you could get back. You would still have all of those changes that you'd made, and you could push that branch up the correct way and get it merged in that direction. So then, and this is what's so fun. So I can git check out master, right? And what if I had just accidentally run that command and I was like, oh my gosh, I'm so hosed. I didn't mean to do that. There's this other thing called reflog. So reflog is kind of similar to the log, but what it does is it gives you a more granular view into your history. One thing I do have to say is that this is one of the things that Git will clean out. So it's one of those things that that does get deleted over time, right? So you only have a relatively short, depending upon how active you are, maybe a couple of weeks period of time where you could correct this change. But what you can see is that like you can see everything that I've done. So I added the exclamation point, I committed that accident, I removed that, the head one, and then committed the accident again, and I reset up there at head at 2. You see I reset, and I'm moving back to that. All right, so right now I'm on master. And what if that was all a horrible mistake? I was like, oh my gosh, I don't know what I've done. It's crazy. Git helps you out so much. So I've just copied the little short part of the SHA, right? That's enough to identify it. And I'm going to do it again. Hard, and then that SHA. So what this is going to do is it's going to act like all that history never occurred. And I'm going to be back where I have... oh, I think I did it too. I didn't go back far enough. But you can see, like, I just added some additional commits that I had blown away before, but now I have them again. Git is amazing. As you learn some of these commands, it will save your bacon over and over and over again. I have no idea how many times I've messed up. Well, you just saw me mess up right in front of everyone. So Git helps you out a lot. Okay, so I pushed up that branch. Did that answer the question? I hope it answered the question. Okay.
I think one thing I would like to add, you need to repeat this, worth noting that doing this changes you've already pushed to GitHub, that you are altering history and possibly screwing other people.
Yeah, so that it's a great addition, right? What he was saying is that if you've done all this stuff and you push it up to GitHub, you are altering the history of all of those commits. And so anyone that has based work off of those commits that no longer exist, their work is completely hosed. Like they'll be so confused about what happened. It's awful, right? Yes. So they it's similar, right? So they wouldn't have the ref log, but they would potentially have similar ways to get back. It just kind of depends. And it's the same reason like a lot of people are scared. There's this other command called git rebase. Git rebase is amazing, and I use it daily to make sure that everything is in a situation. But one of the safety nets of that is that you want to make sure that anything that you're git rebasing, either you're the only one working on that branch, or you have all the work that someone else has done, right? So you don't really want to git rebase a branch that someone else is also working on with you, unless you really know what you're doing. I do it all the time, but it's kind of one of those commands where you can hose other people, and so you have to be a little bit more careful with it. One thing to say, so I've changed the history of master at this point. I'm going to do git push origin master. And, oh no, I didn't, okay. I reset hard. I'm going to reset back to here, where I've actually changed the history. I'm going to do a git push origin master. And GitHub is like, and Git both, are like, no, this isn't a fast forward commit, which means essentially that it's not a safe commit to just push, right? It could mess up some history. Anything that messes with the history, anything that does anything like that, is always going to get this kind of an error. And so what you can do, if you're really, really sure that you do want to push this up, but you want to be a little bit safe, just to make sure that you're not overwriting somebody else's work, is that you can do force, right? And I learned the hard way to not do this anymore. because I blew away a coworker's work, and he was like, what keeps happening? I keep losing this stuff. Like, I'll push up test stuff, and I'm like, I keep forcing over that, apparently. So I learned, so he taught me a new command. So this is awesome, because if you're pretty sure that you want to do this thing, right, you want to make sure that you change history and you want to push it up anyway, but you also want to protect against any changes that someone else has made on that same branch. Force with lease will fail if there are changes on the branch that you don't have in your history, right? So on your current branch, if there's some commit out there that you don't have, this will fail, and it'll say, hey, you can't do it. And then you can just pull that down, you can merge it, you can push it up. So force with lease, if there's nothing in the way, it'll just force the history to get double dash, sorry. It'll just force it out of the way, and it'll overwrite whatever is there, and now you have a new master. Don't ever do this on master. Like, I'm doing everything on master. It should be a different branch, but I already messed up master, and so I'm trying to show you how to fix that if somehow you do. GitHub actually provides a way to make sure that you can't push to master, and I would always always make sure that you add that. Okay. Oh, so now I've messed up that. Okay, so I'm gonna make a new commit. I'm gonna check out my talking branch again. I committed and then push away, and then it looked like it got merged. So what's our state now? Okay, so I'm gonna get rid of this now because I don't want that anymore. I realized I messed up. Git commit. Oh, see, I committed without adding anything, so it'll tell me, hey, you missed something. Fixing. Git push talk. Oh, origin. Well, I'm just gonna do git push. Nope. Oh, okay. I'm gonna specify the origin because I don't want to do that. All right. So now if we go back out here, that one's already merged. And I'm gonna do a new pull request. I'm gonna compare that to talking, and you can see that I fixed that stuff and it's all good. And I'm gonna hit that again. So GitHub offers you some fun options, like you can label it. If you're working on a bigger project, you can label some of the different merge requests. If you're working with other people, you can assign people to do this work. So you just find their name. So if you are the maintainer of this repository, you have the option to merge the pull request. And whenever you do this, it uses just this exact same git command, and it merges that branch into your master branch, right, into your production branch, or into whatever branch you specified. So in this particular instance, we have a talking branch, and it tells us right up here that I want to merge 4 commits into master from talking. So we know exactly what everything, you can see all the stuff that's happening. If you want to actually look into, like, make sure that you understand everything, you can click on any of these commits, and you can actually see the work in each commit. If you go back up to the top and you look at the files changed, this will show you everything that's changed throughout all those commits. But if you wanted to look at a specific commit, you can do it that other way. And then if you have some problems with it, you can write a comment, and that'll show up on their merge request, and they'll get an email about it, so they can go and fix whatever you say. And then once it's all done, you can hit the merge button, you can hit confirm merge, and then if we go and look right here, we can see that there's all these commits because I just merged a bunch more commits. But then the newest commit is this one that merges all of that work that we've added into what we had before, right? So that's that commit that has 2 parents. So there's that. There are also issues. So if you're working on a project, a bigger project, or you want to help out on a project, I would always advise to go look at their issues, because especially on bigger projects, they'll try to find some issues that are better for beginners or better for whatever. Or if you just want to work on something, look at their issues. So an issue just has a title and some text about whatever it is that we need to work on. Wikis are also super helpful. So a specific project can have its own wiki, where you can list, how to install it or whatever it is. Good to always check that out. And then here's the other thing. So there's this fork button. So on a lot of projects, they want you to fork the project and merge all your commits there, and then initiate merge requests from your repository in public up to their repository. And so if you click on this button, that's what this guy over here is for. So you'll see, like in that original one, it's mascot.github talk, right? That's my normal username, and that I own that project. And so then this other one, no, I'm okay. How's that? Oh, maybe I just have the same name. Interesting.
Usually sucks.
Yeah. Oh, maybe I didn't fork it. Oh, that's what my problem is. Sorry. Oh, that's probably my main one. No one look at my passwords. You can't see my passwords. It's fine. Right?
Oh, I see you use spots.
Yeah. Right. Oh no, wait. If that's not right. Okay, good. Okay. Oh, okay. I haven't done it yet. All right. So cool. You're gonna get to see it. Git talk. I think that's what I named it. Oh, GitHub talk. So you can search, right? You can find all these other ones. There's mine. All right. So I'm gonna fork it, right? I'm logged in as this other user, and I'm looking at this thing that I've done, and I want to fork it. And so what forking does is it takes that repository that has been created, and it creates your own repository that you own, right? So you don't own the one that they created, but you own your own. So you can merge into master, you can do anything that you want. And so now I have my own. You can tell, like, this is my username, this is my work. So don't pay attention to that. And then I have the title of the repository that I've copied, and then you can see where I've forked it from. So that way you can always get back to that main repository and see what's over there. And so I'm gonna go ahead and I'm gonna click on this, and I'm gonna edit it because I don't have it locally to edit. So you can totally edit on here on GitHub. If there's something simple you wanna change or readme. And then you come down here, and you can do all the same stuff that you would normally do, right? So you can update README. You can say what you changed, and then you can do something fun. So you can either specify that you want to just merge this into my master branch, the forked master branch, not the main one, because I can't do that. But I can merge it directly into, or commit it directly to mine, or I can create a new branch on GitHub and just go through that whole thing. I'm not going to do that. I'm just going to do it from my master branch. So I'm just going to show you that. So now I've committed it. So now I can do a pull request still, just like regular. But what's cool is that you see how it's mascot GitHub talk. So that's the main repository, right? That's not my forked repository. That's the main one that I've copied it from. And then you can see, like, I want to merge from mine master. So you could choose whatever branch you want. And you can see it's just a change that I had made. So I'm going to create the merge request and submit it. And then if I switch back over to the other side, and I go to pull requests, you can see that now I have the pull request that's been issued from this other project into mine, and I can go ahead and merge it and do whatever I want. Does this all make sense? It's kind of weird. Two remote repositories. Yes?
So forking a repository just makes the same repository but just like.
Yep. It essentially clones it remotely, right? So it's not cloning it to your machine, but it's cloning it both on the GitHub service. Questions? All right. Are there any other questions about this? Be happy to. Is there anything that you would like me to walk through, to click on, to show you? Yep. Uh-huh.
Explain how to get to those windows.
Oh yeah. All right, sorry. So this is my main account on the right, on your left. No, you're right. It's the same, it's mirrored. It's so confusing. So all I would do is I would just open up a new one. I go to github.com, right? I'm currently logged in, right? So if you weren't logged in, let's log out of this one. Oh, no, let's just log out of this one, that's fine. So if you weren't logged in, this is what you would see whenever you go to github.com. If you already have an account, then you just sign in. If you don't have an account, it's free, so sign up, feel free. And then once you are signed in, you arrive on a page kind of like this. and it just shows any repositories that you've already messed with or worked on or whatever. And then you can look at more specific, like this is just a high level overview, like pretty much the recent ones, kind of. And then you can look at all the specific ones. And then if you don't have anything yet, you can just search. So if there was something that you're interested in, GitHub talks, you can go and look at all those, right? And then you click on one of these repositories, and then you can fork from there. You can do whatever you want.
I was thinking more of the ones where you were actually
Okay. Yeah. Oh. So let's. Oh, I'm still logged in here. Okay. So right here, I'm logged in as the user that I forked with, right? And I'm logged into, or I'm looking at the primary GitHub account. Which commands do you want? Like a pull request to create one?
the windows where you're actually typing, like when you first started, like git commit and.
This right here.
Yeah.
Okay, sorry. So all that is just a terminal on a Mac, right? So it's exactly like what's the command? How do you get to? Is it just command like CMD to get to? Yeah, to get to. Yeah, it's all it is. It's just command window. It's just on a Mac. It's just a terminal window.
Okay. Once you open the command window, how do you connect to the GitHub?
If you already have Git installed, then it's just Git commands, right? And so, I'm glad that you asked that one. So what I forgot to say is that if you want to clone something remotely from GitHub, you go to whatever project it is, right? And this right here will give you the link to clone that. So actually let's go to the one I forked, because I don't have that one yet. Okay. So if I go right here, this is one I don't have, and I copy that link, and then I do git, let's cd out of there. So I do a git clone of that project, and I name it copy, because I already have that. That's how you would clone a new repository, right? So on GitHub, they just have it listed right here. Any other questions? That was a good question. She made me remember something that I forgot. And there are other sites like GitHub, right? So there's Bitbucket, there's another one. GitLab, thank you. That's what I can think of. And they're all very similar, right? They provide a lot of similar functionality, and they even look pretty similar. So like once you get used to one of them, you can kind of move around any of them. Any other question? The command?
You also share a link to the slides.
Yeah, I'll push them up on my GitHub, and I'll put that on Slack. I'll put it in the general channel.
I always run into problems when I start using it, so.
Yeah, well, and honestly, if you have any problems, hit me up on the Slack channel if you're in there. I mean, I'm happy to help out with stuff. It's very frequent that I do that work. So I've been using Git for 6 years, 7 years. So you'll figure it out. It's just time. That's all it is. It's not too bad. All right. Well, if there aren't any other questions, close it up.
You said they can hit you up.
Yeah, on Slack, absolutely. Or really anywhere. So my email address is scott.massler@gmail.com. On Slack, I'm Mascot, I think. And then on GitHub, I'm Mascot as well. M-A-S. Where is that? Oh, yeah, M-A-S-C-O-T-T. M-A-S-L-A-R. Right, yeah.
Do you have to be on a certain channel to contact you on Slack, or do you?
If you're in the Code for OKC, I'm also in Tucklahoma. Either of those. Yeah, feel free to hit me up either of those places. I'm there pretty much all day during the workday. And I have it on my phone. All right. Thanks, y'all.